Alrighty, my students, so good afternoon. It is 1:23 p.m. on Wednesday, April the 1st, so happy April Fool's Day. Okay, so the next topic I wanted to cover with you guys is on dilutions. So I know Monday I talked about molarity or concentration, so now I just wanted to go into kind of a similar topic, still talking about solutions, but the next one is on dilutions. Okay, so in our last lecture, we were talking about the difference between something that is dilute and something that is concentrated. So I have two illustrations here. I know they're not exactly the same size and everything, but let's pretend they represent two different solutions, solution A and solution B. Okay, we can say that this is a sodium chloride or a salt solution. Okay, and each of these little circles represent particles of sodium chloride. And then the solvents, so in this case, the solute is sodium chloride. And then the solvent is H2O. So sodium chloride, salt dissolved in water. Okay, so solution A is considered to be more dilute because it has fewer fewer particles of sodium chloride in the same volume of solution than solution B, which has a lot more particles than solution A. So solution B is considered to be more concentrated and solution A is considered to be more dilute. Okay, so say you were given solution B and you wanted to dilute it. You wanted it to resemble something more like solution A. Okay, you wanted this to look like solution A. You wanted it to have the same concentration. So let's say this has a concentration of 1, 2, 3, 4, 5, 6. Let's say 0.6, makes it a little bit more realistic, okay? And then say this one has 3 times that approximately. And so instead of, let's see, I can't do mental math, but say this one is a lot more concentrated. So instead of 0.6, this has a concentration of 1.8. Okay, so how do I go from having a molarity of 1.8 molar to something that's a lot more dilute of 0.6 molar? Okay, so in order to do that, we are going to be using the dilution equation. So the dilution equation I wrote down here is M1V1 equals M2V2. Okay, so first let's talk about what these capital letters mean. So capital letter M stands for molarity. And remember, molarity is your moles per liter. Okay, and your V stands for volume, which is either going to be measured in milliliters or in liters, depending on the problem. Okay, so what about the little numbers? A little number ones is your concentration and volume before dilution. Okay, the little ones are your solution, your molarity, your volume before dilution. And then the little number twos are your solution after dilution, your molarity and your volume after dilution. So if any of you are planning to take chemistry in college, I guarantee you are going to be doing labs that involve the dilution process. So just remember this equation. This is going to become your best friend. Okay, your M1V1 equals M2V2. Molarity times volume of your solution before dilution has to equal the molarity and the times the volume after dilution. Okay, so let's go over a couple of sample questions. So first sample question, it says, how many milliliters are needed to make 100 mLs, 100 milliliters of a 0.750 molar sodium chloride solution? You are starting with a 1 molar solution. Okay, so in order to figure out which one is your starting molarity and your ending molarity, your starting molarity, your M1, is always going to be higher than your M2. Why? Because when in the process of dilution, you are going from more concentrated to less concentrated. Okay, so in this question it says you are starting with 1 molar solution. So this is my M1, my starting molarity, and my desired molarity after dilution is the 0.75. So that's my M2. Okay, and then it's saying are needed to make 100 mLs of the 0.750 molar sodium chloride solution. So this 100 mLs here, that is the volume that I'm wanting to get after dilution. Since it's after dilution, this is going to be my V2. So my unknown is how many milliliters, excuse me. So that is going to be my V1, and that's my unknown. Okay, so when solving these questions, just to make sure you know exactly what information you're given. Oops. My handwriting came out ugly. Just to make sure you know exactly what information you're given, I would recommend writing down the 4 variables, M1 V1 and M2 V2, just to make sure. So again, my starting molarity is 1.00 molar. My starting volume, I don't know what my starting volume is, so that's going to be my unknown. My M2, my desired molarity after dilution, is 0.0750 molar, and my desired volume after dilution is 100 mLs. Okay, so now let's plug this in and solve. There is going to be a little bit of math involved, but nothing major. So again, M1 V1 equals M2 V2. So going from there, we're going to plug in the values that we know. So I'm just going to erase this little M1 here so I have some more space to work in. Okay, but we know my M1 is 1 molar. So I have 1.00 molar times my V1, which I don't know what that is. So I'm going to leave it as V1, my variable, is equal to M2, which is 0.750 molar, times my V2, which is 100 mLs. We're running out of space. Okay, so in order to solve for my unknown, we're going to be using a little bit of math. So to get volume by itself, that's my desired variable, I need to get rid of that 1 molar and move it to the other side. Since right now it's multiplying by the V1, I need to do the opposite, which is division. So I'm going to divide both sides by 1 molar. Cancels out and moves over here. Okay, so my new equation, V1 is equal to 0.750 times 100 ml divided by 1.00 molar. Okay, so now let's go ahead and solve that. So 0.750 times 100 divided by 1. 0.750 times 100 divided by 1. An answer divided by 1 is just whatever answer you got previously. So then my answer is 75. So my V1 is equal to 75. And then to check your units, molarity here, cancel molarity here. So I'm left with units of ml, which makes sense since this is my volume. And there you go. So I would need 75 ml of a 1 molar solution. And then, so quick tidbit here. Since I only need 75 mLs of my starting solution, and I need to make 100 mLs in total, students forget. They're like, okay, well, what am I diluting it with? So since I only have 75 mLs and I need 100, where are those other 25 mLs coming from? So whenever you are diluting a solution, the difference in volume is going to be replaced with water. So in this example, I am going to be needing 25 mLs of H2O. So I need 75 mLs of my starting solution. To that, I'm adding 25 mLs of water to end up with 100 mLs as my final volume. And once I do that, my final molarity, my final concentration will be the 0.75 molar. Okay, so that's my first example. Let me go on to my second example, students. Okay, second example says, what volume of 0.25 molar KCl is needed to make 100 mLs of 0.1 molar solution? Excuse me, okay? So again, I'm gonna start by writing my variables going down. So M1, V1, M2, V2. Again, the ones is everything before dilution. The twos is everything after dilution. Okay, so what volume of 0.25 molar KCl is needed to make 100 mLs of 0.1 molar solution? So looking here, I'll just use a highlighter. I have 0.1 molar, 0.25 molar. The higher value, the higher molarity is my starting molarity because it is more concentrated. So then my M1 is going to be 0.250 molar, and my desired molarity after dilution is going to be 0.100 molar. Okay, so the volume that I am trying to make is going to be 100 mLs again. So my V2, 100 mLs. And then just like in the previous example, I didn't do that intentionally. Just like in the previous example, my V1 is going to be my unknown. So since I already have the V1 equation from the first example, that'll help us here a little bit. Okay, so I'm still going to start from the top though. M1 V1 equals M2 V2, or my M1 is 0.250 molar. My V1 is my unknown. M2 0.100 molar, and my V2 is 100 mLs. Okay, I'm going to do the same thing as example 1. So now my V1 is equal to 0.100 molar times 100 mLs divided by 0.250 molar. Okay, so now let's go ahead and solve that. Let's see. So 0.1 times 100 divided by 0.25. 0.1 times 100 divided by 0.25 is equal to 40. Okay, so my V1 is equal to 40. And then again, double check your units. Molarity cancels with molarity. So my final answer, V1, is equal to 40 mLs of my 0.25 molar solution. And since I want to make 100 mLs, I only have 40 right now. So the difference is going to be 100 minus 40 is going to be 60 mLs of H2O is what I need. Okay, so that will be it for this lecture, my students. So your questions will be very similar to these two examples. If you have any questions, comments, concerns over this, please leave me either a comment or an email, or email me through Google Classroom. You can leave a comment on Google Classroom. But I believe that is it. Thank you for your